Good morning, my dear students. Welcome to the discussion on the subject Engineering Graphics. Under Engineering Graphics, we are going to discuss a topic on projection of planes. Under projection of planes, we are going to solve a problem on plane inclined to both the planes. This is the third solved problem we are discussing under projection of planes inclined to both the plane concept. Now we will enter into the problem. The given problem is a hexagonal plane of side 30 mm has an edge on the HP. Its surface is inclined at 45 degrees to the HP and the edge on which the plane rests is inclined at 30 degrees to the VP. Draw its projections. Now we will extract the data from the problem. Here, the name of the object is regular hexagon. Here the length of the side of the hexagonal plane is 30 mm and one of its side is on HP and its surface is inclined with an angle of 45 degrees to the HP. That is, surface inclination is 45 degrees to the HP. The side which is on HP is inclined with an angle of 30 degrees to the VP. From the above information, we know that the present problem is related to the projection of the plane inclined to both the planes. Here, our objective is we need to draw the projection of the plane. The presentation of this video is divided into two parts. Part A, demonstration and brief overview of the solution. Part B, detailed solution. Then we will enter into the part A, that is demonstration and brief overview of the solution.
This is the horizontal plane and this one is the vertical plane. This is reference line. As we know that the top view of the object is projected onto the horizontal plane and front view of the object is projected onto the vertical plane. This is the hexagonal plane of side length 30 mm is resting on one of its sides, say AB on HP, and its surface is making an angle 45 degrees to the HP. That is, the inclination with HP is seen in the front view. The inclination with HP can be seen in the front view. That is, the inclination of this hexagonal plane with HP is 45 degrees. In addition to that, other information also supplied in the problem. That is, the edge, say AB, which is on HP, is inclined with an angle of 30 degrees to the vertical plane. That is, this edge AB is to be inclined with an angle of 30 degrees to the vertical plane. That is, this problem comes under plane inclined to both the plane. This problem can be solved into three stages. The first stage is initial position assumption. Second stage is surface inclination of the plane with HP. Third stage is the side which is on HP, say AB, is inclined with an angle of 30 degrees to the VP. Now we will discuss first stage solution in brief. In the problem it is mentioned that this hexagonal plane is resting on one of its sides, say AB on HP, and its surface is inclined with an angle of 45 degrees to the HP. In this position, neither in the top view nor in the front view, the true shape of the plane is not visible. But in the case of projection of solids, we need to start with true shape of the plane. For drawing the true shape of the plane, we are assuming that this plane is parallel to the HP. That is, in this position, we are able to see the true shape of the plane. That is, if in the problem it is mentioned that if the surface is inclined to HP, then we are assuming the surface is parallel to HP. In this position, we are able to see the true shape of the plane. Again, the true shape of the plane is visible only in the top view. So, we need to start with top view first. For drawing the true shape of the plane, we need to consider the following condition also. That is, if the hexagonal plane is resting on its side AB on HP while surface is making inclination with HP, then the side AB need to keep perpendicular to the XY line. The side AB we need to keep perpendicular to the XY line. Here for initial position, we need to keep the side say AB perpendicular to the XY line. We should not keep the side AB parallel to the XY line. So it is wrong, whereas this one is correct. That is, if the plane is resting on its side is on HP while its surface is making inclination, then the side which is on HP need to keep perpendicular to the XY line in the initial position assumption. So top view it is a regular hexagon and front view it is a line which falls on the XY line. Because this plane is resting on HP, that's why it image in the front view falls on the XY line. This is the initial position assumption. Then in the second stage, we are tilting the plane in such a way that this plane is resting on its side AB on HP and its surface is making an angle 45 degrees to the HP. That means in front view, it is a line view which is making an angle 45 degrees to the XY line, whereas top view it is a reduced image of the plane because this plane is inclined to the HP. That's why on HP you will get reduced image of the plane. This is the first stage solution and this one is the second stage solution. In the second stage, the surface of the plane is inclined with an angle of 45 degrees to the HP and perpendicular to the VP. And in the third stage, we are going to tilt the side which is on HP, say AB, which is going to make an angle of 30 degrees to the VP. That is, the side AB's inclination with VP is 30 degrees. In this position, we need to draw top view as well as front view of the hexagonal plane. Because the plane is inclined to both HP as well as VP, that's why on HP as well as on VP we will get reduced image of the plane. Here, the side which is on HP, say AB is inclined with an angle of 30 degrees to the VP and its surface is making an angle 45 degrees to the HP. With that we got reduced images both in top view as well as front view of the hexagonal plane. That's about the brief overview of the solution. Now we'll enter into the detailed solution. Under the detailed solution, now we are entering into the first stage solution, that is initial position assumption. In the initial position assumption, we'll start with drawing true shape of the plane. Before drawing the true shape of the plane, first we'll draw XY line. In the problem it is mentioned that this hexagonal plane is resting on one of its sides, say AB on HP and surface is inclined with an angle of 45 degrees to the HP. In order to draw true shape of the plane, what we need to do? We need to assume the plane is parallel to HP. That is, if in the problem it is mentioned, if the surface of the plane is inclined to HP, then we need to assume that plane is parallel to HP. In addition to that, if the plane is resting on its side on HP while surface is making inclination, then that side we need to keep perpendicular to the XY line. So in this position, we will draw true shape of the plane. True shape of this hexagonal plane is visible in top view. Here the true shape of the plane is a regular hexagon. Here the true shape of the plane is a regular hexagon. Here the side length of the hexagonal plane is 30 mm. While drawing the true shape of the plane on horizontal plane, we will keep the side say AB perpendicular to the XY line. The AB side length is equal to 30 mm. With this AB side length, say 30 mm, we will construct the regular hexagon on horizontal plane. Draw side of the hexagon, say AB, which is perpendicular to the XY line. Then complete the construction of the hexagon using circular method. For that, take side length as a radius, one end of the side as a center. Draw an arc with the same radius Other end of the side as a center, cut already drawn arc and name this intersection point as O, with O as a center and OA or OB as radius. Draw one circle. Then this AB as a radius, B as a center. Draw an arc on the circle. Name this point as C. C as a center, the same radius. Draw an arc and name this point as D, and D as a center with the same radius. Draw an arc and name this point as E, and E as a center with the same radius. Draw an arc and name this point as F. Finally, join BC, CD, DE, EF and FA points. This is the top view of the hexagonal plane when it is resting on its surface on HP and one of its side, say AB, is kept perpendicular to the XY line. Then we will draw its corresponding front view. Here this hexagonal plane is resting on its surface on HP. That means its surface is perpendicular to VP. That's why in front view its image is going to be a line view. In addition to that, this plane is resting on its surface on HP. That's why its image falls on the XY line. For drawing the front view, draw projectors through the top view points of hexagonal plane, say A, B, C, D, E and F towards the XY line. Because this plane is resting on its surface on HP, that's why its image falls on the XY line, and also this plane is perpendicular to VP, that's why in front view its image is a line. With this we completed first stage solution. Then we will move towards the second stage solution. In the second stage, the hexagonal plane is resting on its side, say AB on HP, and its surface is inclined with an angle of 45 degrees to the HP. In this position, that is, the plane is inclined to HP and perpendicular to VP. We need to draw front view as well as top view of the hexagonal plane. Here, the side of the hexagonal plane, say AB on HP. That's why that's image in the front view, say A dash B dash, falls on the XY line, and in front view it is a line which is making an angle, say 45 degrees. Here this 45 degrees is nothing but inclination of the plane with HP. Then here draw 45 degrees inclination line. Here we are going to reproduce the first stage front view into the second stage front view such that this A dash D dash line is going to incline with an angle of 45 degrees to the XY line. For that, take A dash D dash as a radius, A dash as a center, draw an arc, then name this point as D dash, then take A dash C dash as a radius, A dash as a center, draw an arc on A dash D dash line, then name this point as C dash. After that, draw projectors through the points, say A dash, C dash, D dash, etc. vertically downward direction, and also draw projector through the first stage top view points, say A, B, C, etc. horizontally rightward direction. After that, locate the intersection points. Here, this is the projector coming from A dash and this is the projector coming from A point in top view. Both are meeting at this particular point and name this point as A1. Similarly, this is the projector coming from B dash and this is the projector coming from B, and both are meeting at this particular point and name this point as B1. Similarly, locate remaining intersection points. Then join these intersection points in a sequential order with straight line segment. This is the second stage top view when the hexagonal plane is resting on its side, say AB on HP, and its surface is making an angle 45 degrees to the HP. Because the plane is inclined to HP, that's why on HP we'll get reduced image of the hexagonal plane. With this we completed second stage solution. Then we'll move towards third stage solution. In the second stage solution, the hexagonal plane is resting on its side on HP and its surface is making an angle 45 degrees to the HP. Whereas in the case of third stage, what we need to do? The side which is on HP, say AB, which is perpendicular to the XY line in the second stage, is to be tilted with an angle of 30 degrees to the XY line. 30 degrees to the XY line. In this position, we need to draw top view as well as front view of the plane. That is, in the third stage, we need to reproduce the second stage top view into the third stage such that the side which is perpendicular to the XY line in the second stage, say A1 B1, is to be tilted with an angle of 30 degrees to the XY line. This inclination line can be drawn in this direction or in this direction also. In order to easily reproduce the second stage top view into the third stage, we are going to enclose this second stage top view within a rectangle, say 1, 2, 3, 4. That is, here A1 B1 side need to fall on this 30 degrees inclination line. That is, the side of the rectangle 1 to 2 falls on this 30 degrees inclination line. So here construct the rectangle, and with reference to the rectangle we'll copy the second stage top view into the third stage top view. For that, locate a point 1 here and 1 to 2 along the 30 degrees inclination line. Locate point 2. Then complete the construction of the rectangle. Then the points in the second stage top view points, say A1, B1, C1, D1, E1 and F1 are to be transferred into the third stage with reference to this rectangle. For that, take 1 B1 as a radius, 1 as a center, draw an arc, with that you will get point B1. With 2 as a center, with the same radius, draw an arc on 1, 2 side, with that you will get point A1. That is, 1 to B1 as well as 2 to A1 is with the same radius. Similarly, with the same radius, draw an arc on 3, 4 side, with 4 as a center, with the same radius, draw an arc on 3, 4 side. With that you will get points, namely, say A1, B1, D1, E1. Then we need to locate C as well as F points. That is C1 as well as F1 points. Take 2C1 as a radius, 2 as a center. Draw an arc on 2, 3 side. Similarly, 1 as a center. Draw an arc on 1, 4 side. Name this point as C1 and this point as F1. Then join all these points in a sequential order with straight line segment. Copying the second stage top view into the third stage with the given condition, say the side A1 B1 is inclined with an angle of 30 degrees to the VP is completed. Then we will draw its corresponding front view. For that, draw projectors through the points, say C1, D1, E1, F1, A1 and B1 towards the vertical plane, as well as draw projectors through the second stage front view points, say A dash, B dash, C dash, D dash, E dash and F dash horizontally rightward direction. Then locate the intersection points in the third stage front view. Here, this is the projector going towards the vertical plane through the point C1, and this is the projector coming from second stage front view point, say C dash. Both are meeting at this particular point and name this point as C1 dash. Then this is the projector going through D1 point towards the vertical plane, and this is the projector coming from second stage front view point, say D dash, horizontally rightward direction. Both are meeting at this particular point and name this point as D1 dash. Then this is the projector going through third stage top view point, say E1, and this is the projector coming from second stage front view point, say E dash, and both are meeting at this particular point and name this point as E1 dash. Similarly, locate remaining intersection points. Then join these intersection points in a sequential order with straight line segments. This is the required final stage front view when the hexagonal plane is resting on its side, say AB on HP. That AB side is making an angle 30 degrees to the VP and its surface is making an angle 45 degrees to the HP. Now we will see the pencil usage details. Here the top views as well as front views of the hexagonal plane are with H pencil. The projectors are with 3H pencil. Dimensioning is with 2H pencil. Related to the dimensioning details, the side length of the hexagonal plane is 30 mm. That is, all dimensions are in millimeters. Then we will see the overall summary of the solution. Here, this is the first stage solution when the hexagonal plane is resting on its surface on HP and perpendicular to VP. And this is the second stage solution when the hexagonal plane is inclined its surface with an angle of 45 degrees to the HP and resting on one of its sides, say AB on HP. And this is the third stage solution when the hexagonal plane is resting on its side, say AB on HP. That AB side is making an angle 30 degrees to the VP and its surface is making an angle 45 degrees to the HP. This is the required solution for the given problem.
If you have any queries or doubts related to the present solved problem, you can mention it under comment section of this video. I'm happy to answer it as quickly as possible. For more videos on engineering graphics, visit the links provided under the description of this video. Keep learning on knowledge sharing. Stay blessed. Thank you.